matching observations. Here's our data step, which match merges these two data sets on IMP-ID and then creates the output data set, IMP's AUC. This data step is similar to the data steps shown in earlier match merges. Let's start at the beginning of the execution phase. SAS has already created the PDV and the descriptor portion of the output dataset with the four variables: first, gender, IMP-ID, and phone. SAS looks at the first observation in each dataset. SAS determines which bigroup should appear first. These two observations are in the same bigroup. SAS reads the data from the current observation in the first dataset and then the second dataset into the PDV. Then, SAS writes the contents of the PDV to the output dataset as the first observation. The values remain in the PDV as SAS begins the next iteration of the data step. SAS now looks at the second observation in both datasets. Here's a question: what does SAS look for now? SAS checks to see if the current observation in either of the datasets is in the same bigroup as the data in the PDV. The current observations are not in the same bigroup as the PDV. This is the first non-matching observation that SAS has identified. Because current observations are not in the same bigroup as in the PDV, SAS reinitializes the PDV. Here's a question: which bigroup comes next? In the current observations, the IMP-ID value ending in 151 comes before the value ending in 152. So SAS reads the second observation in IMP's AU into the PDV. The current observation in the second dataset is in a different bigroup, so SAS does not read the data into the PDV in this iteration. In the PDV, phone is still set to missing because there is no phone number for this employee in phone C. SAS writes the data in the PDV to the output dataset as the second observation. Once again, SAS returns to the top of the data step and moves down to the third observation in IMP's AU. In phone C, SAS is still looking at the second observation. These two observations are not in the same bigroup as in the PDV. SAS reinitializes the PDV. Then, SAS reads the data from the current observation in the first dataset and then the second dataset into the PDV. SAS writes the data to the output dataset as the third observation. SAS continues processing the data step in this way until the end of both files is reached. The completed output dataset contains both matches and non-matches. Matches are observations that contain data from both input datasets. Non-matches are observations that contain data from only one input dataset. This dataset has two non-matches, one from each of the input datasets. You've seen that SAS includes both matches and non-matches in a merged dataset by default. To create a merged dataset that includes only matches, you need to modify your data step. First, you can use the n equals dataset option to identify which input datasets contributed data to each observation that SAS outputs. Then, you can use the subsetting if statement to output only those observations that contain data from all the input datasets. If you want to create a merged dataset that contains only non-matches, you can use the same technique. When you specify the n equals option after an input dataset in the merge statement, SAS creates a temporary variable that indicates whether the dataset contributed data to each output observation. After a SAS dataset name, you specify the n equals option in parentheses. Following the equal sign in the n equals option, you specify a valid SAS variable name. In this example, the n equals option is specified twice, once for each of the input datasets. However, you can specify the n equals option just once, or for any number of datasets in a statement. Here's how SAS processes the n equals dataset option in the data step. During the execution phase, SAS creates a temporary variable in the PDV for each instance of the n equals dataset option in your code. Each time SAS reads data into the PDV, SAS assigns a value to the temporary variables to indicate whether the associated dataset contributed data to the current observation. If a dataset did contribute data, SAS assigns a value of 1 to the associated variable. For example, both datasets contributed to the data that is shown here in the PDV, so the value of both temporary variables is 1. If a dataset did not contribute data, SAS assigns a value of 0. For example, the dataset phone C did not contribute data now shown in the PDV, so the temporary variable cell is set to 0. 1 and 0 are the only possible values for the temporary variables that you create using the n equals option. Now let's look at some different data in the PDV. Here's a question. What are the values of imps and cell for the data now shown in the PDV? Both datasets contributed to the data in the PDV, so SAS assigns the value 1 to both imps and cell. Let's look at one more example of data that SAS has read to the PDV. Here's a question. What are the values of imps and cell for this data? This data is a non-match that comes from phone C but not from imps AU. SAS sets the variable imps to 0 and cell to 1. You might be wondering whether variables that are created with the n equals dataset option appear in the output dataset. These variables are only available during execution. As you can see by looking at the partial output dataset here, SAS does not write these temporary variables to the output dataset. Now that you've added the n equals dataset option to your data step, SAS will know which observations are matches and which are non-matches from either of the input datasets. Next, you can add a subsetting if statement to write only the matches or only the non-matches to your output dataset. We want to create an output dataset that includes only matching observations. To do this, we can write a subsetting if statement that refers to the variables we created using n equals. Here's a question. What subsetting if statement will select only matches? To select only matches, you can use this subsetting if statement if imps equals 1 and cell equals 1. Here's another question. How many observations does the output dataset contain? The output dataset contains only 2 observations for the 2 employee ID numbers that match across the input dataset. The input datasets. You can also create multiple datasets by using the n equals dataset option and equals dataset option and conditional statements that include an output statement. For more information, click Details. Now you're ready to use the n equals dataset option and the subsetting if statement to perform a different task. Suppose you want to combine imps AU and phone C again. But this time, you want to create datasets that contain non-matches from one or both of the datasets. To start, you'll select non-matches from the first dataset and create an output dataset named EMPS-AUC2. To select non-matches from the first dataset, we'll start with the same data step that we've been using. Notice that we've changed the output dataset name to EMPS-AUC2 so that our new dataset won't overwrite the output dataset that contains only matches. Now we just need to add a new expression to the subsetting if statement. Here's a question. What expression selects only non-matches from EMPS-AU by specifying values of the temporary variables? The subsetting if statement shown here will select only non-matches from EMPS-AU. The temporary variable EMPS must be equal to 1 or evaluate to true. The temporary variable cell must be equal to 0 or evaluate to false. Here's another question. How many observations are in the output dataset? The output dataset EMPS-AUC2 has one observation, as shown here. Now, try answering a question about selecting non-matches. Suppose you want to match-merge the same two datasets and include the non-matches from either dataset. In other words, you want the observations in the first dataset that have no match in the second dataset, and the observations in the second dataset that have no match in the first dataset. You'll name the output dataset EMPS-AUC4. Selecting non-matches from either dataset is a little trickier. Let's figure this out bit by bit. Here's a question. To select non-matches from either dataset, what values of EMPS and cell do we want? Both EMPS and cell will equal 0. Now, try answering this question. What subsetting if statement selects non-matches from either dataset by specifying the values of EMPS and cell? This subsetting if statement selects non-matches from either dataset. Both EMPS and cell must be equal to 0. Or, both EMPS and cell must evaluate to false. Notice that you must use the operator OR instead of AND. Here's another question. What happens if you use the operator AND in this expression? The subsetting if statement tries to select observations that did not come from either dataset, so the output dataset has no observations. The output dataset EMPS-AUC4 has two observations, as shown here. The first observation is a non-match from EMPS-AU. The second observation is a non-match from phone C. Now, try practicing in your SAS. You're ready to work with some new datasets that have a more complex relationship. EMPS-AU-US contains employees from Australia and the United States. Phone O contains their country and office phone number. You want to match-merge these datasets by the common variable country to create a dataset named EMPS Office. Here's a question. How many values of country appear in each input dataset? Only the two values AU and US appear in each dataset, and each value appears more than once. These datasets have a many-to-many relationship, You can match-merge data that has a many-to-many relationship in two ways: using the data step techniques that you've already learned and using the SQL procedure. It's important to decide what you want your output to look like because these two techniques create different output. Here's the data step we'll use to match-merge these data sets. When you run a data step that match-merges data with a many-to-many relationship, you'll see this note in the SAS log. Here's a question. How many observations do you think the output data set will have? In these two data sets, there are 12 possible ways to match input observations with matching values. However, when SAS processes the data step for a many-to-many merge, SAS does not make all possible combinations. In other words, SAS does not produce a Cartesian product. The data step output has only 6 observations. ProcSQL is the SAS implementation of structured query language. ProcSQL is part of base SAS, and you can use it with any SAS dataset. You can often use ProcSQL as an alternative to other SAS procedures or the data step. The ProcSQL step shown here match merges or joins these two datasets on the variable country. Unlike the data step, ProcSQL does generate all possible combinations of matching observations. So the ProcSQL output has 12 observations. For more information about ProcSQL syntax to create a dataset by joining multiple datasets, click Details. Here's what you learned in this lesson. Now, test your understanding by